start with logistic regression today. First, quick introduction about logistic regression. So what is meant by logistic regression? So first, we will see what is logistic regression. Is a method used in machine learning for binary classification problems. If you want to find out a value or price or stock price, if you want to find a value, then you have to go for linear regression. If you want to classify, the problem is in the form of classification, then we have to go for logistic regression. For example, we have taken one example, that is social ads. Social ad means based on the data, we have to identify whether the customer will purchase the product or not. Okay, either the person will purchase the product or he will not. Similarly, for the prediction of disease, either the person have the disease, have the cancer, or he will not have the cancer, or he will have a diabetes, he will not have a diabetes. Like that. In that kind of application, if you have a problems like that, you want to predict problems like that, we have to go for logistic regression. So thus it is called binary classification problems. Usually the output is either 0 or 1. In linear regression, the output is a values. It is a continuous values. But here the output, that is the dependent variable column, will be either 0 or 1. It is used for in the cases where spam detection. Spam detection means either the mail is a spam or it is a not spam. In those case, classification of mails, email, and then disease diagnosis, like I told, customer loan prediction, like that. The output is a probability function. Here, there the output is not a probability function; it is a linear function. But here, it is output is a probability function. Based on the probability, you will either classify that as 0 or. You can see in this picture, will purchase health insurance, yes or no? So this is an insurance company. They want to find out whether the customer will purchase the health insurance or not. Okay. Based on the age, they want to classify. So obviously, if the age is very less, in the terms of 18, 19, then most of the people will not purchase the health insurance. If the age is around 40 or 35, 50, the people who purchase the insurance, health insurance, will be more. So from the graph, you can see this is the age and this is the output, that is the dependent variable or target. Okay. You can see at the age 18, a more number of people are not purchasing the health insurance. So this is in the red dot. Some people are exceptional. In the 50s also, they are not purchasing. They may not have the awareness of that. Okay. So that may be the case. But most of the people are here. If you see yes, in the yes level, most of the people around the 30s and 40s are purchasing the loan. In some cases, the person with the earlier age is also purchasing. That is exception. So this is the output. This is the output of the logistic regressions. Maybe yes, or it may be Y or no. So the equation for this one is based on the probability function, like I already told. Ln of P by 1 minus P equal to B0 plus B1 x1. We already know what is B0 and B1. So these are the coefficients. Okay. So similar, this equation is similar to the linear regression. Wait a minute, someone is. So the coefficients are same based on the B0 and B1. You are determining the values of the probability functions. I will not go into deeply the mathematical equation. And if you want to add more features into our problem, that means the health insurance, purchase of health insurance is also based on age, income, level of education and family, because it may not be uh, based on the age alone. It also based on the income. It may also based on the level of education or family or single. So other factors may also be uh, leads to this problem. So we are including more number of features. That's why it is called multiple logistic regression. Okay. So there we have used a gradient descent to classify the, to reduce the, to optimize the error. Gradient descent we have used. Here we are going to use the maximum likelihood function. So what this maximum likelihood function is? So first we will map the problems like this. Okay, in the two-dimensional. That means what it says is this person, the person who are purchasing the loan, yes, this person is 0.03 and this person is 0.54 because it is a probability equation. Mainly it is a probability equation. Okay. And then the person is purchasing the loan around this age is 0.92. This is the probability. And 95% of the people around this age are purchasing. And this is the probability, 98% of probability the people are purchasing this. Okay. So how it will classify this as 0 and 1 is, look at this one. So this curve is called sigmoid curve. Okay. So here this is the probability. So this is the least probability. Okay. Now you can come into the 35 age. When you have the point of intersection in the sigmoid curve, it is around 42%. Okay, that means 0.42 or 42%. 42% of probability this person is going to have the, will purchase the health insurance. So that is the meaning of this. And around 45 years of age, this person will purchase the insurance. The probability function is, the probability is 81%. Okay, 80%, 81% of the probability that this person will purchase the insurance. Okay. How it will classify this as yes or no is based on this one, the threshold value. We will fix the threshold at 50%. Okay, below 50%, if the probability is below 50%, then we will make that person as no. That means you will not have the, you will not purchase the health insurance. When the percentage is above 50%, we will make them as yes. You will purchase the insurance. Based on this threshold value only, we are making the person, we are classifying the person as either you will purchase the loan or not. Okay. So keep that in mind. Based on that only, this graph will be there. So how the maximum likelihood is classified, is determined is because this shape of the curve, okay, may be of anything. Okay, it may be like this. Can you see the light line? It may be, the curve may be like this. The lighter line curve is there, no? Okay, the curve may be like this. Can you see here? I will show in the pen. So here the curve may be like this also. So here is one line is coming. Okay, the curve may come like this also. The curve may come like this also. It may be of any slope. So why I am choosing this one is based on this maximum likelihood. Okay, at this point only the error is minimum. Okay, how the classification is done is here 0.03. This dot is 0.03% of probability that he is purchasing the loan. This point, okay, that means this dot, when you, this dot is 0.54 probability, and this point is 0.92, and this point is 0.95, and this point is 0.98. So I am multiplying all the probability of this function. Similarly, you have the dots here, red dots. So that means these person are not purchasing the health insurance. Okay. So what is the probability of that one is 0.01. Okay. So that is the probability. That is the point. He is not purchasing the insurance. But we are focusing on since it is in the no, I have to include 1 minus 0.01 because it is the no probability. So this is yes probability. So to make that equal, I am making this as 1 minus 0.01. And similarly, this point is 1 minus 0.04. And this point is 1 minus 0.10, like that. And multiplying all this probability of all the data sets, I will get the likelihood as 0.001, some value I'm getting. So like that, I will calculate for all the different slope lines. Okay, like this, many lines. Okay, the curve which has the highest value will be considered as a maximum likelihood curve. In this case, this is the maximum likelihood curve. Are able to understand this? So this is how we are finding out a curve which will have less error. Okay. In the linear regression, we have used gradient descent to find out this, to reduce the cost function. Here we are using maximum likelihood calculation. Okay. Because it is a probability, we are going to use maximum likelihood method. So that's all. The first step is importing the library functions. So import. So first, before that, you have to connect. You can see here it is not connected. I'm just connecting it. So 3 important libraries is needed for machine learning. What is that one? NumPy, Pandas. Pandas is used for to access the CSV file, table file. Okay, tables, and then matplotlib, matplotlib as PLT or PyPy. Say is showing that matplotlib.python. Okay, thank you. So this is the 3 common library function that they are using for any machine learning algorithms. Just run it. You can have the tick mark. That means your notebook has been connected with the server. The next step is importing the dataset. Either right click here, upload, or use this upward arrow. Just click it. So I'm interested in social network ads file. Okay, so just upload it. So how will you import the data set? So this is the command. The data set is the variable. PD is the pandas dot read underscore CSV. So this is social network ads dot CSV. So that is the file name. So now this has been stored in the variable data set. Okay, so stored in the variable data set. Now just run it to check it whether the data set is uploaded on your notebook. After that, we want to see data pre-processing. Okay, data pre-processing, where we will use the data pre-processing. Before that, we will split the rows and split the columns. So dependent variable and independent variable. So just we will look at our data set. So what is the command that is used to look at the data set? Data set. So that is the variable where my CSV file is stored, dot head. So you can see the first 5 rows. So what are the columns here? Age, estimated salary, okay, and purchased. Age, estimated salary, and purchased. So what is the age? Age is a independent variable, and estimated salary is a independent variable. Purchased is the dependent variable. So I already told it is a binary classification method. The output is, or the dependent variable is either 0 or 1. 0 means is not purchasing. 1 means is purchasing the product. How they are determining whether the customer is purchasing the project or a product or not, based on the age as well as the estimated salary. Okay, if the salary is high, definitely the customer may purchase. And it also depends on the age factor also. Okay. And we have another function to see our data, that is data set dot tail. Okay. The data set is the name of the data frame. Okay, tail. If you put tail, you can see the last 5 rows. The maximum count is 399. Okay, and if you want to see the shape, just put data set dot shape. So these are the very useful function. From that we can able to see all the interesting things. Okay, data set dot shape. So 400 comma like that. Okay, so if you want to info means dot info, you can see all those things. If it is null, okay, this null function is there. So like that you can see. So that we have seen in the previous programs. Okay, so that is to understand about the data set. Okay, so with that we will finish that. And the main important part is splitting the features and the target. So from the data set, what are the target we are interested is, we are interested in the age and estimated salary in the independent variable and purchased in the dependent variable. So how we are going to do is, okay, use the same code that I given before. Okay, so what I am doing here is I am just dropping the columns purchased alone. So if you want to drop the column, you have to give axis 1. Or if you want to drop the row, we have to give axis 0. And then y data set equal to purchased. So that means I am keeping the purchased column alone in the y. Okay, just run it. I'm going to see what is x. X contains age and estimated salary now, and y contains only the zeros and ones. So that is the purchased column. Okay, here you can see the purchased column. And then splitting the data set into training set and test set. So how we are going to do that? We have to call the function from sklearn model selection, import train split and test split. So this is the library function in the sklearn that is used for train split and train and test split. After that, we have to tell that how many percentage we are going to keeping as training as well as for testing. So why we need to split is, the whole data we are splitting 25% of data we are using for test. Okay, and remaining 75% we are going to use for train. The train means to learn. For the model to learn, we are going to keep 75% of the data. For the test, we are going to keep 25%. Random state is, you can give any number here, but why we are giving this random state is, to take the algorithm. If you give the same number, the algorithm will take same types of variables for the test size as well as for the training size, training data set. If the random state is somewhat different, if I'm giving 3 and if I give some other number, the samples it will take differently for test size as well as for the training. Okay, I'm just running over it. Then we can see the X train. So here we have 300 values and then Y train. Then X test as well as Y test. Okay. So if you give a random 0, the same samples it is taken here for the test and the train is same. If you give some other random value, then this data will be different in the X test as well as in the X train. That is the next is feature scaling. So this thing you have to learn it. Okay, I will open the. Okay, so look at this data pre-processing. In the data pre-processing is nothing but import the data, cleaning the data, split into training set and test set, as well as feature scaling. Okay, so we have to see what is feature scaling. So before that, I will just give you a quick review of it. Training set and test set is your complete data. That means under your data has been separated into two. For training 80% and for testing 20%. So this 80% has been given for learning and the remaining 20% is given for testing. Okay, we are going to give only the values and it will predict the price. And then finally, we will see the predicted values and the actual values from the data set are same or not. So based on it, we will evaluate the model. Okay, so that is the purpose of training set and test set. Are able to understand clearly now? 80% of the data for training and the 20% we are using for predicting, for testing. So for when you are testing, you have one predicted values and you have the actual value here. Finally, if you compare these two values, we will able to evaluate the model. Okay. So what is feature scaling? So this is very important. When you have different ranges of values, for example, x1 here is in the hundreds, okay, and x2 is also in the hundreds, and x3 also in the hundreds, whereas x4 is in the form of tens, okay. So this is in different range, and this is in different range. When you use this column for learning and for training the algorithms, what will happen is this will have more importance when compared to this one because this value is higher. The model doesn't know this is a money and this is some other value. So in our case also, we have two things: age and salary. Obviously, the age will be in the tens. Below 100 only the age will be. But the salary is up to lakhs also will be there. Okay, from thousands to lakhs. So the range of these two parameters or the features is different. So in those cases, we have to scale the values. Okay, and last class we have seen the encoding process where we have to encode is when we have the characters yes or no or any cities, then we have to give the encoding thing. We have to encode that. But here we have to scale because it is in different range. There are two types of scaling. One is normalization, another one is standardization. Okay, normalization is x minus x minimum by x max minus x minimum in the column. In a column, you have x, okay, and then that is the actual value, and you have the minimum value and you have the maximum value. So if you apply this here, you will have the values from the range 0 to 1. So this is called normalization of the values. And standardization is x minus mu, Okay, mu is the mean and is the standard deviation. So based on this, you will have one values. Okay, it may be any range, -3 to +3 or -2 or +2 based on the values. Okay, so there are two types of method. One is normalization, another one is standardization. So I already told. So it is a salary and this is the age. When you look at this one, the difference between these two is 1000 and the difference between these two is 1. Here the difference between these two is 8000 and the difference between these two is 4. What do you think? Which one is closely related? You will say these two are closely related. Okay. But after applying the normalization, you can see here this values become 0. Again, it is between 0 to 1. From that we can say which one is mostly highly differ is it is between 1 to 0.4. So you can see the difference. Okay. So that's the important thing we have to learn. Okay. So where you are going to apply that is when you have different ranges in the feature. When you look at our social network ads data set, you can see here age is in the form of tens and estimated salary is in the lakhs and thousands. So we need to apply the standard deviation here. Okay. So where the standard deviation is there is again it is in the scalar. Okay, scalar standard scalar. If you go through that, you will have you can see scalar dot pre-processing standard scalar. Okay, from that you can take the you can learn more about the standard scalar. So this is the code for that scalar pre-processing import standard scalar. Okay, so this is the library function we are calling, and then we are creating a variable sc for standard scalar function. Okay, and we are training fit transform means we are going to train all our values. We are going to apply transform to all the values, and we are going to replace that. We are going to transform that, and we are going to store in the same column as xtrain. Okay. Here also we are going to apply the standard transform on the x test and we are going to store that in the x test itself. Okay, so just running it. Very simple. Python is very simple. Now you can see all the values has been changed. Okay, it's all in the even range. Okay, so it's not in the tens or not in the thousands and all in the form of -1 to some values. Okay, it is in a it is in an equal range, and then in the x test also it is in the same thing is happening. After that only we are going to apply the going to train the model using logistic regression. So how to get the logistic regression? SQL again logistic regression. You will have the logistic regression function. So you will have a lot of parameters here. You can see. Okay, but mostly we will make this as default. We want to do any change. Okay, in any exceptional case, then you can alter this one. Otherwise, you can keep as it is. So no need to alter anything. Next we go for logistic regression. It is same. No difference. Similar to linear regression from sklearn, linear model, import, logistic regression. There linear regression, here logistic regression. Classifier equal to logistic regression, random state equal to 0. Okay, we are maintaining the same random state. And then we are going to train the model classifier as with xtrain and ytrain. So what is xtrain? Xtrain is age and salary, and ytrain is whether is purchased or not 0 and 1. So after training that, we have the model for us, okay, with the random state 0. And then we are going to predict, okay. After prediction, we will come to the new value. So for prediction, what we are going to do is, we are going to use the predicting test results, okay. Okay, these things you have to learn from sklearn matrix, import, confusion matrix, and accuracy score. So in the previous case, we have used R square matrix, but here we are going to use confusion matrix and accuracy score. So what is that? So just go through that sklearn confusion matrix, whatever it is, you just go through and you have the matrix over it. Okay, so sklearn confusion matrix and accuracy score. So these are the two metrics that you are going to use. So what is confusion matrix? Can you look at this? Okay. The values is either 0 or 1. The output is either 0 or 1. So first what we are going to do is, we are going to train the model. Okay. Okay. So first, after training the model, we are going to predict the values. Okay. After predicting the values, we are going to compare the predicted result as well as the test result. Okay. So after that, when you are comparing, the values may be true or it may be false. If it is true, that means if the predicted result is 0 and the actual values is 0, then it is correct prediction. So this is the green color. And if the predicted value is positive, that means 1. And if the actual value is negative, that means it is predicting wrongly. So that means we are going to put it is in the false prediction list. And if the predicted result is 0 and the actual value is false, then it is in the false negative. It is also an error. If the predicted result is negative, that means 0, and the actual value is 0, then it means correct. Okay, so that means it is correct prediction. So these two are correct prediction and these two are wrong prediction. So based on this, we will find the confusion matrix is a matrix that is that gives us which one is, how much value is correctly predicted, how much value is wrongly predicted. Okay. From this, we will calculate the accuracy scores also. Okay, it produces the error. The reason for this is I am not determining what is Y predict. Okay, so there is an error because I missed that code. Okay, can you do that code for confusion matrix? Wait a minute. There is some error. So I have to do the Y prediction. So what is Y predict? Y underscore predict equal to, what is the model name? We have created classifier. Classifier is the model dot predict. We are going to predict the values for the X test. Okay, capital X underscore. Now if you run, now that here you can see 65%. That means predicted value is positive as well as actual value is positive. So 65%. And then false is 3. It's very good. And here it's also false. False means what? Predicted is negative, but actually it is positive. Okay. And then 24. 24 means predicted is negative and the actual value is also negative. So that means these two values 65, 624 is correctly predicted, but these three are missed by the model 8 and 3. Accuracy score is the percentage of correctly predicted total value, that is 0.89. So 89%, this is correct. Accuracy here is 89%. Now we are going to see that how we are going to predict the new result. So this is almost this is same as linear regression. So here I'm giving the values, my values as 30 years of age and then 87,000 salary. And as usual, I'm converting that into array format and I'm reshaping it because we have to give the values in the 2 dimensions. So I'm just reshaping it. After reshaping, I am applying the standard scalar transform. Okay, after applying the transform, I am giving that into the model and the model is predicted that, okay, if the prediction is 0, then the person is not purchased. If the prediction is not 0, you will purchase the project. So just run it. Here you can say it is 0. That means the person will not purchase the. So this is how we can create a model using logistic regression to solve the binary classification problem. 0 or. Okay. So most of the steps are similar when you compare with the linear regression. Most of the steps are similar. The data pre-processing, uploading the data, everything will be same. And if you want to apply the standard scalar is also same because these comes under data pre-processing. Where the code will change is in the training. We have to use what type of algorithm that you are going to use. Only this area will change. For this, we have to go and see in the sklearn. After that, the confusion matrix and this accuracy score is a little bit different because we are dealing with probability functions and the output is either 0 or 1. So for that, we need to use this one. If the output is a continuous values, then we have to go for R square metrics. So these are the metrics that is most commonly used in the machine learning algorithm.